Hey everyone, I'm Dr. Surjit Singh. This is Letcode problem number 31, next permutation. Let us begin. We are given an array of integers. Together they form one of the many possible permutations of the given integers. We have to find the next permutation of these integers. If the given permutation is the largest number, then the next permutation means the smallest number consisting of the same n integers. In the brute force method, we will find all the permutations and then compare them to find the smallest of all these permutations that are larger than the given permutation. But the number of permutations is huge even for a moderate value of n. For example, if n is 15, there are more than a trillion permutations, and in the present problem, n can take values as large as 100, for which the time is unimaginable. For this reason, we will not discuss this method any further. Now we will look at a new method that uses linear search. The logic of the solution is very interesting. Consider this array of 5 integers that form the number 53412. Using the same digits, if we find all the permutations that are larger than this and sort them, we find that the smallest of these 7 is the first number. So in our case, 53421 is the required permutation. Let us see how we can arrive at it quickly. As we are interested in the minimum increase, we must start inspection from the units place. We are lucky because swapping of the last two digits gives us a larger number. Now consider this number and make a copy of it for reference. Once again, we start the inspection from the two of its rightmost digits, that is the units place and the tens place. If we swap 5 with 1, it won't give a larger number because they are already in the descending order. So we inspect the next pair. Even here, 6 is larger than 5. Now we inspect 3 and 6. Yes, 3 is smaller than 6. Therefore, 3 is the pivot because increasing its value will have minimum increase in the final number. And it has to be replaced with one of the 3 digits to its right. The replacement of 3 must be by a number larger than it. Obviously, the 3 numbers to the right of the pivot will always be in the decreasing order. As the increase in this number has to be minimum, we start the search from the right side. We find that 1 is not greater than 3, so it cannot replace 3. Next we inspect 5. Yes, it is greater than 3, so we replace 3 with 5 and get this arrangement. We notice that while 5 has reached its proper position, 631 have not, because it is clear that these 3 numbers remain in the descending order even after the swap of 5 with 3. But for the minimum increase in the final permutation, they need to be in the ascending order. So in the last step, we reverse the order of all the 3 integers that are present to the right of the pivot position. Two-pointer method is used for this purpose. In the first step, we swap 6 with 1. Now, in the next step, we move both the pointers towards each other. When the 2 pointers meet or cross each other, the process stops and we get the desired number. Before we write the Python program, let us consider an edge case. In this case, all the digits are sorted in the descending order. Pivot will go out of bounds and its value will be -1. In this case, pivot replacement is not applicable nor possible. All the digits are present to the right of the pivot and therefore they all have to be reversed. And we get this number. as the next permutation. We can verify easily that this is the smallest number. We come back to the previous example once again. Now we know all the program steps. Step 1 is to find the pivot position. To begin with, we try if the integer at the tens place can be our pivot and compare it with the number next to it, that is at the units place. We continue to move the pivot to the left. While pivot is within bounds and the number at the pivot is greater than or equal to the number next to it, in the present iteration 5 is greater than 1, so another iteration is required. So we decrease pivot by 1. In this iteration of the loop, we try 6 as the pivot and compare it with 5. Once again, 6 is greater than 5, so one more iteration is required. Now we check if 3 is smaller than 6. Yes, it is. So now we have found our pivot position, which points to 3, and we come out of the loop. Remember that if the entire list is in descending order, search for the pivot will fail, and when the loop terminates, pivot will go out of bounds and its value will be -1, in which case no replacement at the pivot is possible. The if statement of the program ensures that in case pivot is -1, the swapping process is bypassed and we will directly move to the next step, that is reversing the order of the numbers to the right of pivot. In our present example, pivot is present and we start with the process of finding the number which can replace it. For the replacement process, we start with the last digit and we run a loop that continues while the number is less than or equal to pivot. Note that we cannot stop at the equal numbers because replacement of equal numbers with each other does not give a new permutation. We find that 1 is smaller than 3, so we reject it because the replacement of 3 with 1 will decrease the number. Next number is 5. We find that 5 is the first number in our search which is greater than 3. So the loop terminates. Now we will swap this number with the pivot. After swapping these numbers, the number at the pivot position has reached its required position. Last step is to reverse the order of the numbers on the right side of the pivot. That is from position pivot +1 to the end. In the present case, we will reverse the order of these three numbers. The reverse function uses the two-pointer method. Start gets the value pivot +1 and it becomes the left pointer. Last number of the list becomes the right pointer. We start the while loop that runs till the two pointers meet or cross each other. In the first iteration of the loop, we swap 6 with 1 to get this arrangement. Now we move the two pointers towards each other. The two pointers meet each other and the loop terminates. And the present arrangement is the required permutation. Also remember again that if all the numbers are in the descending order, the value of the pivot becomes -1. In this case, swapping of the number with the pivot is skipped and the execution directly moves to the next step in which the order of all the numbers will be reversed. When the pointers cross each other, we come out of the reversing loop and get the next permutation as required. 9 swaps with 1, 6 with 2, and 5 with 3. These swaps give us the new permutation in which all the integers are in the ascending order. Let us now discuss the time complexity. We scan the list linearly in a loop to find the pivot position, so it is linear in n. The second loop is about searching the number to swap with the pivot. This loop is also linear and starts after the first loop has finished, so time complexity becomes of the order of 2n. Next, we start with reversing the numbers. This loop starts only after the first two loops are over, and there are at most n by 2 iterations. So the overall time complexity is of the order of 3n, which is the same as of the order of n. No extra space is used in either of the three loops. Further, we modify the input array to get the required permutation, so the space complexity is independent of n. Thank you for your time. I look forward to your comments and feedback. See you in the next video. Thanks and have a great one.